Welcome to the volume of Prisms podcast. So first of all, let's talk about three-dimensional figures. So polyhedra are three-dimensional figures. So a polyhedron, so polyhedra is the plural, polyhedron is the singular. A polyhedron is a three-dimensional solid figure in which each side is a polygon and are joined at their edges. And so we've been dealing with two-dimensional geometry. Now we're going to be dealing with three-dimensional geometry. The word polyhedron is derived from the Greek poly, meaning many, and the Indo-European hedron, meaning seat or face. So a polyhedron is a figure, a three-dimensional figure, solid figure, that has many faces. And a polyhedron has no curved surfaces. The common polyhedron are pyramids and prisms. This lesson we're going to be working with prisms. Let's look at some non-polyhedron, just to compare. So non-polyhedra, the following solids are not polyhedra, since a part or all of the figure is curved. So cylinders, cones, spheres, and torus are not polyhedrons. So you're probably familiar with cylinders, cones, and spheres. A torus looks literally like a lifesaver. It's a ring. So it's a three-dimensional ring, and that it's all curved surfaces. So all of these, either in part or in whole, are curved, nothing but curved surfaces. So prisms are what we're going to be dealing with. So let's learn a little bit more about prisms. So prisms are polyhedron. Prisms are named by their bases. A prism has two parallel faces, called bases, that are congruent polygons. The lateral faces are rectangles in a right prism. So right prism just means that the sides and the base meet at right angles. And the two bases are aligned one over the other. So in a right prism, those lateral faces are rectangles. If our prism is oblique, so an oblique prism sort of leans. The two bases are not aligned one over the other. And it literally, if you kind of think of the Leaning Tower of Pisa, the figure literally leans because those two bases are not directly over one another. Right, so here we have a right prism. They would have lateral faces that are rectangles. An oblique prism, lateral faces are parallelograms. The bases could be rectangles as well, or parallelograms. But if your prism has any sides that are not rectangles, those always have to be your bases. Right, so here we have a right rectangular prism. Since every single side is a rectangle, really whichever two opposite sides I want to be the bases could be the bases. But that oblique triangular prism, the bases have to be the triangles because the sides have to be either rectangles or parallelograms. The edges of the prism where the lateral faces intersect are called its lateral edges. The lateral edges in a prism are congruent and parallel. And that's true whether it's a right prism or an oblique prism. The prism always has lateral faces that are parallelograms. Right? So rectangle is a type of parallelogram. Right? So your lateral sides are always parallelograms. So those triangle sides, they could never be the lateral sides. Those have to be the bases. Right? So we learned a little vocabulary here about our prisms. Common language, so we can talk about prisms. And then later on, we're going to be looking at right cylinders. And even though cylinders are not polyhedron, they do have a lot in common with prisms. Cylinders are three-dimensional closed surfaces. In general, when we use the word cylinder, we're referring to a right circular cylinder with its ends closed to form two circular surfaces that lie in parallel planes. In other words, the cylinders that you're used to, a right cylinder, the two bases are going to be directly over one another. Sometimes we also have oblique cylinders, and our bases are not aligned. Right? The two circles are not one over the other. So cylinders are not polyhedron since their faces are not polygons. In many ways, however, a cylinder is similar to a prism. A cylinder has two parallel congruent bases, as does a prism, but the cylinder's bases are circles rather than polygons. Right? But a lot of the techniques we learned for prisms are going to apply to cylinders. because they have those two congruent parallel bases. Here we have the right cylinder and the oblique cylinder. So even though those bases aren't aligned in the oblique cylinder, they are still parallel. They're just not one over the other going straight vertical. They're still parallel, it's just on a diagonal. So a cylinder with bases that are not aligned one directly above the other is an oblique cylinder. An oblique cylinder looks like a cylinder that's been pushed over. The volume is calculated the same way as a right cylinder, except because the sides of the cylinder are slanted and not perpendicular to its base, we have to draw a height that's perpendicular to its base. So on the right cylinder, the height is going to be the vertical distance from the base straight up to one base to the other. Right? It's not going to be along the side because the side slants. All right, so definition of volume. This is in your notes. So we have a little background, a little bit of vocabulary. So now let's start looking at volume. So definition of volume is the amount of cubic units a solid can hold. Right, when we're finding area, we use square units. Volume is going to use cubic units. So what is volume? The volume of a solid body is the amount of space it occupies. Volume has units of length cubed. We measure volume as a cubic unit. The formulas for volume all use the same measure to calculate volume of any given figure. They use the area of the base and the height of the object. Volume is literally how many layers of the area a given unit high could fit in a three-dimensional object. So for instance, let's say I'm measuring here, we have cubic feet. Right? So if I'm measuring in feet, it's literally how many layers of that area I could fit, right, in that cube there. So volume of prisms. The volume of, and this is in your notes, the volume of, so all the rest is background, but we're getting right to the meat of finding the volume of prisms. The volume of a prism is the product of the base area and the height of the prism. And this is true no matter what kind of prism you are working with. It's always going to be area of the base times the height. And the height is that straight vertical distance between their two bases. So the height of the prism is the distance between the bases. Right? So you have to be careful. We use height in more than one way. So the area of the base is the little, so that big B means area of the base. So big B, come on. And we're just waiting, there we go. Waiting for my writing to occur. So that big B means area of the base. We find the area of the base by taking the little b, the little base. In this case, base is referring to a side. Sometimes it's called length. Has the same meaning. Okay? Just one unit of linear measure. And then little h is the height of a two-dimensional figure. Right, so sometimes if it was a rectangle, we might call it width. Oops, missing the B there. There we go. If it was a triangle, we might call it altitude. But we don't want to confuse that with big H. And big H is the height of the figure. And that's the height of our three-dimensional figure. And another way to think of that height is that it is the distance between the bases. Right? And you have that right in your notes, and you should underline that. So the height of the prism, that's big H, is the distance between the bases. And then big B is the area of the base. Not to be confused with one of the measurements along the base that we use to find the area. Okay? So it'd be nice if we didn't use the same words for different things, but this has different meaning. So if base and height you don't like that, you can call it length and altitude. Then it'll have a different name. All right, so here we have some rectangular prisms, and these are in your notes. There's a triangular prism, and that's gonna be in the notes a little later on. But we have this one here. I think this one is in your notes. Yes, it is. It's right underneath the triangular prism. All right, so let's find the volume of these two figures. All right. So we're going to find the area of the base and then multiply it times the height. Right? So volume is area of the base times the height. This is a rectangular prism, so it really doesn't matter which side I call the base. But once I've labeled the base, the height is going to be the distance between one base and one side and the opposite side. And so what I usually do, though, is I just label the bottom rectangle on a rectangular prism. I just call that one the base. I kind of prefer looking at that than looking sideways. So that's going to be my base, which means the height is going to be this distance between those two bases. All right? So let's find the area of the base. All right, this is a rectangle. Right? So to find the area of a rectangle, you multiply the base, little base, or if you like, you can call it length, times the height, but little height, or you can call it width. Right? So the area of our base here is going to be 8 inches times 3 inches, or 24 inches squared. Right? We measure area in squared units. The volume is going to be that area of the base, which is 24, times the height of our figure. And the height is the distance between one base and the opposite base. So 12 inches is the height of our figure. And if we multiply those together, we find that 288 inches cubed is the volume of that rectangular prism. Okay? When you're finding volume, don't forget to include your units. If there are no units, just call it units, literally. All right, let's find the volume of this rectangular prism. All right, I'm again going to call the bottom here. Let's make this a little easier to shade. All right, so the bottom here, I'm going to call that the base. Right? And then that means that this would be the opposite base is up here. So this distance here is my height, my big height. All right, so volume again is the area of the base times the height. The area of our base here is going to be 4 centimeters times 6 centimeters. So we're going to have an area of our base of 24 centimeters. I want to call it inches. The last one was inches. 24 centimeters squared. All right, so that's the area of that base of that rectangular prism. To find the volume, we take the area of the base, and to find out how much space is inside there, we're going to multiply that area of the base times the height of the prism. So 24 times 5, that's going to give us a height of 120 centimeters cubed. Right? These are pretty easy, and I have to say, finding the volume of rectangular prisms is pretty easy. We'll get a little bit trickier when we find the volume of triangular prisms, and we'll do a few word problems or problems you have to think about, like this one. So find the volume of a cube with edges of 7. But you were only given one measurement here. But now if we think back to a cube is made up of, so each face on a cube is a square. So all 6 faces of a cube are squares. And we know that the sides of a square are all congruent. Sides of square are all congruent. So if one is 7 inches, so is this side. And so is this side. They're all 7 inches. Right, so let's use our volume formula for prisms. And I could just draw it up here. It's already shown for me. I will call that the base. Right, so the sides here, these are all 7. Here, I'll only write 3 7s in. Right, so volume, remember, is the area of the, actually, I'm going to write over here. Why am I crowding my writing when I have all this space over here? So volume is the area of the base times the height. Our base is a square, so it's going to be 7 times 7, or 7 squared, which means our area of our base is 49. And it doesn't say what, so 49 units squared. We don't know whether this is inches, feet, centimeters, miles. And then the height, and actually on those last ones, I wanted to make sure I labeled height. And I plugged it in, but I did not label it. So let me rectify that by labeling it. So let's label our height, because I want to make sure, because sometimes students get, especially when we get to the triangular prisms, they get a little confused on the height of a triangle that makes up the base and the height of the prism, which is the distance between the bases. So this height here was 12 inches. So if we label it on the easier ones, maybe we'll remember how to find it on the more complicated ones. And this height here was 5 centimeters. All right, now I took care of that. So you add that to your notes. Hopefully I didn't change the slide too fast on you. All right, so our height here is going to be 7, because every side on the cube is 7. So our volume is just going to be the area of the base, which is 49, times the height, which is 7. Okay? And that's going to give us a volume of 343 somethings units cubed. Now, there is another way we could actually also think of this. Since we got the base by multiplying 7 by itself, and then we just multiplied that 7 squared by another 7, we could also think of this as 7 cubed. So another way to think of this volume for the cube anyway is that this was 7 cubed, which is 343 units squared. Sometimes that's helpful when you're solving a word problem involving a cube, just to remember that all the sides are the exact same length. So like for instance, if I knew the volume, I could find the measure of a side just by taking a cube. Okay? Right, so hope this one made lots of sense for you. Oh, and this one is not in your notes. I don't think. Nope, this one is not in your, oh yes it is. It is in your notes. I lied. I'm sorry. That we've skipped one, and I think we're going to get to it a little later. But there is one, it is in your notes. It's about 2/3 down on the page there. There we have that one right there. Continuing on. All right, so here's the one that is just under the ones we did earlier. And we'll get to that triangular prism that's in your notes a little later on. If the volume of a cube is 512 centimeters, what is the length of each side of the cube? Well, I just gave you a big hint on the last problem, right? So one way we can think of volume for any prism whatsoever is the area of the base times the height, right? That works for all of our prisms. But the cube's a little special, right? So the cube, remember, I had on the last slide, has sides that are squares. Right? So they all have the exact same measure. So the sides are all the same. And that means also that the height, and I should put big H there, the height of the cube is exactly the same as the side measures. So because they're all exactly the same length, for a cube, just a cube and nothing else, we can also think of volume as side cubed, where the side here is just the linear length of one of the sides. Right? So this is just a linear length along the edge here. Right? So the side here is an edge length. And since all those edge lengths are exactly the same, right, we know that it's just the same number multiplied by itself 3 times. So if the volume is 512, and that's equal to the sides cubed, if we take the cube root of both sides, right, and make sure you got your steps in here. Well, what times itself 3 times is 512? Well, I know the answer to that. And maybe you would have a calculator handy, and you could use that. But let's say you don't have a calculator, and you're not sure what that answer is. Right? How would you find it? Well, you could use your buddy method. But instead of just 2 buddies, this is 3 buddies. Right? So this is a medium security prism, and it takes 3 buddies to spring you. Right? So you have to have 3 buddies. And all you have to do is break it down into its factors. So let's pretend I don't know what the cube root of 512 is, and I don't have a calculator handy. Right? So what divides evenly into 512? Well, even if you're not sure of many numbers, you're probably sure that 2 is, right? Because that's an even number. Right? So 512 divided by 2, right? So 2 is going to go into 5 twice. Right? That's going to be 11, so I'll go in 5 times, and then I'll have 12, so I'll go in 6 times. So 512 divided by 2, half of 512 is 256. Right? So 256. You might know that that is 16 squared. Maybe you do, maybe you don't. Well, now you do, as I just told you. All right? So, but don't circle one 16 and cross off another and say 16 square roots of 2, because this isn't a square root, it's a cube root. Right? So 16, we can break that down, right? So those are 4s. Right? 16 times 4 times 4 is 16. And we can break the 4s down, right, because 2 times 2 is 4. Right, so now we have broken this down into its prime factors. And it takes 3 buddies. Right, so 1 buddy gets out, and 2 buddies sacrifice themselves. 1 buddy comes out, and 2 buddies sacrifice themselves. 1 buddy comes out, and 2 buddies sacrifice themselves. So the cube root of 512 is going to be 2 times 2 times 2, which is not 6. It's 8, right? Because 2 times 2 is 4, and 4 times 2 is 8. Sometimes students want to say 6 because they see 3 2s. Well, this isn't 3 times 2. This is 2 times itself 3 times. So 2 times 2 times 2, that is 8. And 8 is the cube root of 512. And that means all of our sides measure 8. Well, I think I'm near the end of this podcast. Let's see what the next problem is. And I'm going to do this one. Let's do this one in class. All right? We have done a good chunk of the prism problems. Prism, not prison. And so we'll finish this problem and this problem. This one's a tricky one. And these 2 problems in class. And then we'll look at finding the height of a triangle, and then look at that, we're up to whiteboard practice. So we'll finish this rest of this lesson in class on Monday. Thanks for watching the podcast. Bye for now.